So in this post we're going to look at creating a soft alpha UI mask in Unity 3D. So why look at creating a soft alpha mask when Unity already comes with a mask UI element? Well, the UI element that comes with Unity is it's a hard alpha mask. So regardless of the alpha values on your masking texture, they're considered either on or off. So you can't, there's no blending at all on the alpha channel for the actual mask itself. So we're gonna, or I have created a component that we can then have a soft mask on effectively. So let's have a look at the one we get with Unity and compare it with the one I've written. So on the left here we've got the Unity version of the mask UI component, and on the right is my soft mask. You can already see just from this screenshot that there's alpha blending being used on the mask itself here, and also you can see that the mask texture here, the alpha values are being used correctly. They're not just on or off, they're a lot more accurate. Whereas here we've got none of this. There's just like a kind of a little bit of a grey border around there where the alpha changes, and here there's just nothing. It's just on or off, as you can see, and the same with this component as well. So there's 1, 2, 3, 4 components there. So let's have a look at the Unity ones, how I've set those up. They're pretty much the same as I've set up my components. There's a little bit different because obviously I guess this is more of a workaround than a replacement for the mask UI. We'll come to that in a bit, and we'll just go over that in a moment. But let's have a look at the Unity ones. So the Unity scroll area, this one's just a texture that we've got in a mask. So I've got a scroll panel which has got the image for test mask 3, which is this crazy looking texture thing. I think I got it off some kind of Maori tattoo design or something. I just thought I'd give her something that was a bit more detailed, and turn that into just an alpha texture. You know, like a sprite. So alpha channels on off, and there's a bit of a blend, as you can see. It's hard to see in there. Make these bigger. I don't think you can you? Oh yeah, it's at max anyway. You can just about see that there is a border around that on the alpha channel, which we can, as I say, we can see there, but we can't see in the intrinsic one that comes with Unity. So this scroll panel, it's got a scroll rect on it. I can move horizontally, vertically. It's got the scroll mask script, which is the one that comes with Unity. Show graphic or not, doesn't really matter. And then we've got the content. The content, I've just got this massive. I took this photo when I was going for a run in the park, and basically it's using that as the texture behind to be masked, and it's just got nothing on it. It's just the item itself. So the scroll panel has got the source image. The scroll rect has got the content as my content element there. So if I click that, it shows. As I say, both horizontal and vertical is elastic, elasticity settings, everything else. So just set up like you would any regular one, and then the same with the text one as well. I'll give it a bit of a background, which is the space wallpaper I've got there. The scroll panel again set up pretty much the same, except I'm only going to have a vertical scroll. Could switch that on if we wanted to, but the horizontal on as well, but there's no real need. There's a scroll bar on there as well, so the scroll panel itself's got the vertical scroll bar kicked in. The content again is the content within it, and the content component is just simply text scripts with a load of text in it, all sized and scaled and whatever else. So in comparison, so let's have a look at the scroll area for the texture version. I'll explain why I've got two different versions in a minute. So that's the content for that. So the content for my version of the mask. So the scroll panel's pretty much the same, except you'll notice there's no mask on it. Again, same source image. Well, it hasn't got the same source image actually, because I'm using the mask for the source image on that one is the same as the background image, where I don't have to do that in this scroll panel. I can give it its own source texture, the mask itself, so I'm going to pass into the content. So that's my script running on it, and obviously you've got to tell it the mask area, so that's how it knows what area needs to be over the screen needs to be cut off basically from the rest of the content, and then you can give it the alpha mask texture that you want it to use. You'll also notice I've added a cutoff. So you know in like in Unity you've got the alpha, the transparency shaders, and you've got the cutoff transparency. So this means you can set you know, put a tooltip on it. So at what point to apply the alpha min. So the range is from 0 to 1. So if I move that up, you should see that alter as well. So as I'm moving that up, you can see the alpha value. So now when it's at 1, obviously everything's off, so it's not letting anything through on the it's masked everything effectively. So you can already see that if you've got quite a funky alpha mask, you can apply the cutoff, and you can do some quite nifty transition effects effectively with that. So let's have a look at these two running. So if I run it now, oh, and a thing to note as well is the canvas. At the moment I've got it in world space. I think I've got my camera's perspective as well, so we should be able to move around in world space and use these canvases just like we would any Unity canvas. So I should, if I can, on my script I've got my camera, I've got a translate rotate controller as well that I'll show you that in a bit. It's very, very simple. As you can imagine, passing the keys I want it for the controls, and then can set the speed of how fast it can translate or rotate. So in world space, so you can see we can look around the whole thing. It means up my translate speed to 10. Rotate's probably okay. Right, so that's cutting off there because my camera file plane. This is set that a bit bigger. Right, so as you can see, just like with any Unity UI component, we can move around them. Another thing is, I don't know whether that's bitmap levels or whatever else, but you get on the Unity intrinsic mask, you get this, I don't know whether it's bitmaps or whatever, but it's using the same texture, and so I don't know why it does that, but the Unity one just seems to have this odd cutoff. But when you're up close to it, and that's fine. But as you can see, the alpha is much cleaner on mine, or I think it is. So it's more true to the actual alpha texture itself, whereas that's a bit more chunky and crumbly. So now what we should be able to do is I should be able to put my mouse over this and drag and move the texture about, which I can do. So as you can imagine, this texture is actually a huge texture, and the mask is just trimming it off. So, and I can just move that about, and this is what, as I say, all happening in 3D world space. I'm going to do the same with the Unity one as well. So you know, it works exactly the same as that. If we can probably, let me put my camera back to where it was. Oops. Set the rotation as well. Okay, back to where it was, and then we can look at that canvas again, but in overlay. So, and there's no point me going to staying in perspective, so I'll go to orthographic. So now even in orthographic mode, we've still got the same level of control. I can still move my camera about, but it's not having any effect because it's overlay. So wherever the camera is, it's overlaying it on the screen. So yeah, so it works exactly the same in overlay mode. And also if we flip that over to camera, so obviously render camera set to that, to my camera that I'm using, and again it's fine, can render it over. So yeah, so that works pretty cool. Now for the image, it was pretty simple to do. I kind of need to know to be able to do it, to do the cough. This camera, that's cool. Yeah, so to be able to do the cough, I kind of needed to know where against the texture we're going to effectively mask a cull, where the 4 points were in texture space. So in the texture space, the text coords on the rendered texture, and then all I had to do was then map the mask UV, the mask alpha against that. So that was pretty simple to do. I could do all that in texture space. Where it got a bit tricky was with the text one. This gave me no end of headaches, the text, because each character, if we have a look in wireframe, so if, with your fonts, with your text, UI text, each and every single one of them is geometry in its own right. So I couldn't go and have, you know, like a global texture UV value to manipulate on those. So effectively what I've done with the texture one is do it in world space rather than in texture space, and that was a bit of a pain in the bum because there was a method I was missing. I assumed wrongfully that the rectangles that I'd get back from the UI controls for the text were in world space, and they're not. There's a function that you need to use to do that, but I'll show you that when we get to the script. But let's have a look at the actual the texture one running as well. And again, the content, that's for the Unity one. The content for the texture one, again, it's using my script. You'll notice mask area is obviously its container, and the alpha mask off. I'm using this, so it fades it out at the top, fades it in from the bottom when you're scrolling it, which looks quite cool. So if we have a look at that, so now you can see the Unity one is using the exact same mask, but you'll see when we scroll that, the cutoff at the top, because the alpha's it's either on or off. So at that point, it's literally just slicing it off. It's not blending the alpha channel at all. So you can, and even at the bottom, it's not even using. There's a fine fade there, isn't there? And it's not even using that fine fade. It's literally seeing that as the alpha channel's on. Whereas through my implementation, you can see already we've got a nice fade there already. Scrolling through, and we can change that to. So if we were to change that to, I don't know, that test mask, you can see it's now using that. Mask texture. We could switch for that one. So now it's almost like only in the middle. It's going to render the texture fully. So again, you can, and again with the ramp, you can move the ramp up and down, and again we can. Yeah, there's loads of transition stuff you could do with that. So that's pretty much it really. So it's just giving us the ability to have a better, I guess, a better alpha check against the mask. Again, what are we in? Camera space. I think if I flip to world space, it'll screw up all the cool. Oh no, it did. It was okay. And camera's perspective still. So again, we can move around our elements, and we can still use this even in world space. The scrollers. Same with the Unity one. These textures. One thing I will explain as well while we're in the editor is that on the controller for this, I've had to put the mask script itself on, but I've disabled it because if it's on it tends to send it doolally. And I think what that's doing, just by that being present, stops the content of this being accessible outside the bounds. So if I was to remove that, what would happen? So my text, I've scrolled my text all the way up to there. So this text is effectively from here all the way up to here. It's just that my shader's cutting it all off. And the same with this. When I scroll that all the way to there, the text is effectively there, but the mask is trimming it off. So if I remove that, what will happen now is I'll try and access the UI element above it, but when I do, because it's now picking up my text to do it, so that's why I add in the UI mask and disable it. And now, okay, if I go to use that, it lets me do it, which is quite cool. So that's just saved me having to work out how to disable the mouse on those elements. I just wanted to be able to do it all in the shader, so that's what it does. So let's have a look at the shaders actually first. So I've got two shaders. I'll show you the soft mask shader for images first. So this is basically using Unity. You can download all the built-in shaders for Unity off the site. So yeah, let's have a look. I might have to Unity3D caps locks on. So if we go to get Unity, I think it's off the downloads. Patch release, so where is it? I'm sure it's on here. Few tutorials, vlogs, blogs. Okay, additional downloads, that's it. Yeah, so you can get all the built-in shaders and download those. So basically I went in, had a look for the UI component shaders, just took a copy of that, and then I've just modded that in my code. So effectively loads of this stuff actually came with the base shader. I've added in I think the min-max, alpha mask, alpha UV, and my cutoff flags. All that there just came with the intrinsic, and the same with the tag stencil. Or again, all I've modded is even all this was there. All I've modded is, so in the vertex shader, actually not on this one I haven't changed anything. I've added in my alpha mask, UV, min max off, and cutoff, and I've basically just, that's all I've added into that shader, to that basic shader. And effectively all it's doing is looking at the text coordinates of this texture, and if it's not inside the min and max of that scroll area, it basically sets the alpha to 0, so you can't see it. Otherwise, it takes the current text coord minus the min and divided by my alpha UV, so that basically gives me the pixel coordinate in relation to the scroll area in the mask texture. And if it's less than my cutoff value, you know, so we can set the cutoff for the transition thing, it's set to 0. Otherwise, it's set to whatever's been pulled back from the mask. And that's it. That's all it does. It's really simple. So if we have a look at how we're calculating the min and max for that, and the alpha UV, that's all in my soft mask script. So again, we've got the material we want to get hold of. We actually need to know the canvas data, but not for the texture one. It's sorry, for the image one. It's for the texture one. I'll show you that again in a bit. The mask area we're going to apply to, so that's just a rect transform. So as you see, I've put some tooltips on the publics so people can know what they are. I've also set it so I can execute in edit mode, so that when you're building it in the editor, you can actually see the thing working, rather than having it looking all really messy and then run it and it looks fine. You can see what's going on in the editor as well. The alpha mask itself to be used, so that's the texture passed in, and then the cutoff value. So I'll set up variables for the alpha UV, min max. The rest of these are just used for calculating what's going on, to get to the min max and alpha UV. So I will need to know what my rectangle is for calculating my position in either, actually not in world space, just in texture space. So first thing it does is it checks, see if I'm actually being applied on an image, and if I am, I'm going and automatically setting that image's material to my material using my shader. That's just so you don't have to go around setting and changing the contents materials. So you can see it's using my soft mask there. So if that was set to empty or something else, the only drawback of this, I guess, is if you have written a text shader for your content, it will override that. That's one of the caveats, I guess, to using this, whereas I would imagine using it in the Unity one, you won't have that problem. So that's something to watch out for. It will overwrite the material used on the content. So that'll automatically set up the content to use my shader. I'll go through the texture bit, texture version in a moment. Let's have a look at the one for the image. So every update, I'm going to set the mask, because obviously things pretty dynamic. You're moving the texture about underneath. You want to change the way the mask is behaving. So handily, I've commented this to remind me what I was thinking at the time of coding. So effectively, this is getting the areas of the two rectangles. So the mask rectangle and my rectangle. So the content. So the image effectively, or text. So that's my mask rectangle. So we'll come straight down to the else, because it's not text. So we're looking at the image one. So what we're going to do is you're going to need to do our calculations in text space. So we know that text space is from 0, 0 to 1, 1. So in DirectX, top left hand corner to bottom right hand corner. So I need to now find out the min and max text coordinates to be then applied to my texture. So I'm doing that by getting the center. I can also get my alpha UV, so that's going to be the offset to get the mask texture into the mask area, and that's basically just done by dividing the two rectangles by each other. So that will give me then the UV offset for that. I can then set my min and max, so I'm basically setting them both to center. So that's my starting point for the min and max. So now I need to know the size of the area of the mask rectangle, which is basically going to be the rectangle width and height halved, because obviously from the min point we just want to move it out half the distance to the left and up, and for the max we want to move it half the distance to the right and down, and that gives us rectangles min and max extremes effectively. So that's moved it to there. Now I need to move the min and max values into text space, and to do that, just basically dividing min and max by the content rectangle, and then because it's the space is between 0 and 1, rather than we need to shift basically effectively the values 0.5 to the right and down, and then that sets the min and max perfectly. And then we just pass these values into the shader. So that's the min and max set. The alpha mask, which is the texture to use. If it's not texture, which is not, then we need to pass in the alpha UV, and then the cutoff value. And as we saw, those values are then used in the fragment shader to basically do the culling, really, the masking of the image. So again, pretty simple that was. And if we now have a look at how I'm doing it with the text, it's still pretty simple, but the pain in the bum for me was all in moving the rectangle size coordinates into world space, and also because I'm doing it in world space as opposed to texture space, you need to know basically what the render mode is of your canvas. So if I'm using the screen space, I'll explain this extra condition here in a minute, but that's to do with the editor. So you need to know whether it's in overlay, because the rectangle's not in the same space as it is when you're in camera or world. So camera and world seem to be giving us actual world space values, whereas in screen overlay I don't think it's even screen space, so I'm going to call it canvas space because that's the best I can think of describing it. And so to move the rectangle values from canvas space into world space, I have to even the point, the position of the things in canvas space as well. So effectively, to get the point, I do an inverse transform of the mask area position, and then the size is effectively what the mask rect comes back with. Whereas in screen space camera, render mode and world, I can do this little function here called get world corners, which I wasn't aware of. Simon Jackson actually pointed me to, which was really useful. I was having a right bloody nightmare trying to get it to work with textures, and that just solved a load of issues. You wouldn't believe the amount of calculations I actually got it working in camera space, but the calculations I ended up doing to do it was just I just knew it was wrong. I knew that the space I was starting in wasn't right, but I just didn't know how to get the bloody world space from the rectangle. So effectively that's intrinsic method, which comes with your rect transform, or return the corners. So the size is effectively I just take two opposing corners and subtract them from each of them. That gives me the size. The position is the actual world space. World space position actually is the transform position, and then effectively, regardless of which render we've got, we take the position to create the min and max, which is minus the, just like down here. So that's slightly different in that we're doing the divide first and then applying it, whereas we're doing it all in one here. So it's the min is the position minus the size halved, and the max is the position plus the size halved again. So the shade is a little bit different for the texture. Again, it's the standard UI shader. I've added in these few parameters. Again, min, max, alpha mask and cutoff. As I say, I don't need, oops, yes, that one. I don't need alpha UV for this because I'm operating in world space rather than text space. And I've made a change in the vertex shader, so I've got a world position 2, which was already in there, I think. Was it the default one? Oh no, I must have added that. Okay, I thought that was in there. So I've added world position 2, assigned it to color semantic, just purely. I guess I could use text coord, either one. So that's going to be my position in the world within the pixel shader, and to get that, it's effectively just the inputted vertices multiplied by the object's matrix, world matrix, effectively. These, I'm sure you know already, are intrinsic Unity structures. Good old Google. Of course, you can use Bing if you really want to. 23 3D. I should have these bookmarked, really, shouldn't I? So there's loads of shader lib built-in values. So object to world is the current model matrix, so that's the world matrix for the model being actioned on. So in our case, in this shader, that's going to be applied to the texture quad that's coming in. So yeah, you've got loads of others, stacks, tons of them, really good. Save you having to create them yourself. So yeah, so we just transform the vertex position into world space. I don't think I need to do that, but I did it just in case for that half texel inset. Yeah, so we've got world position now. That basically comes into our texture shader, and as you can see, this is pretty much the same as the other shader now, except instead of using the texture coordinates, I'm just using the world position I've just calculated in the vertex shader. So if the pixel's world position now fits within the world positions of the min max extremes, or doesn't, sorry, then I'll set the alpha to 0. If it's in the mask, so now just like before, we pull out the alpha mask, but we're using the UV minus the max divided by min max, and that basically transposes the texture coordinate for the alpha max. Can't talk. Alpha mask, which then gives me the texture value for that. If it's less than the cutoff, we just set it to 0. Otherwise, now here it's different because I'm applying I'm multiplying the alpha by the actual color alpha, and that's because if you don't, because the texture, I guess you could do that in the other shader as well. Actually, I might change that. But anyway, for textures, because the text has got, obviously it's got alpha values in it, we need to also apply those. So you don't want, otherwise you end up with big squares effectively of colour. You don't then get the font represented in the quad. And again, yeah, that's pretty much it. So it turned out to be quite a simple solution once I realised that the rectangle space wasn't actually in world space anyway, or in any other space other than canvas space, I suppose. Yeah, so that's that. That's how I've got it to do a soft UI soft alpha mask using shaders and a script. Oh, I was going to go over the script, wasn't I, for the whole of text. So as I say, for text it's a little bit more complicated. I need to know if it's a text or not. Again, just like in the image, I'm pulling in the right shader material for it, and again I've got those stored in resources UI, so that's where they live. But I also need to get the canvas, so instead of having to pass, so when we set it up, instead of having to pass the canvas in here, so going, oh no, that's the canvas I need, and then having to do that for every component, I've got it so that it's basically going to run up each of the parents in the transform nodes until it hits the canvas, and then it's just going to assume that that's the canvas that it's using. I can't really see you nesting. You might, but if you do nest canvases, this probably won't work. So get canvas, basically we start off with our transform, and while the canvas is null, I'll put that limit in just in case it never finds a canvas for whatever reason. You don't really want it sitting in this loop forever. I guess you could put that in a coroutine, but then you wouldn't really know if it, mind you, yeah, you could put it in a coroutine, I guess, but I haven't. So I put these limits on, so if it goes back 100 components, doesn't find one, it's just going to drop out, and you'll have editor errors, I guess, when you're trying to use it. So while it's not, canvas isn't set, just goes in, gets component, is it a canvas? If the canvas is still null, it just calls get parent transform, which effectively just goes and returns the parent transform. Thought there was going to be more in there. That line could probably just be that. Let's replace that method. But anyway, that's what it does. So that then comes back, populates our canvas, and then yeah, as I've noted here, for some reason the mask control. So that's so what that's going to do is, if the container for this doesn't have a mask, it's going to add a mask for it. It's then going to disable the mask on it. So if we look at that on here, so my scroll panel, if I remove that now and then run it, my script will run through and it's added it for us. So now you're not going to get that where it's over you know, blocking other UI components effectively. So yeah, so that's pretty much it. That's a soft alpha UI mask. Yeah, I hope you found it useful. And any questions on it, then by all means post it on the Facebook page, and I'll do my best to answer. Hope you've enjoyed it. Hope you find it useful.